This is a third video for the assembly programming and reverse engineering course, and in this video I will talk about logical operators and truth tables, and this is how a computer is able to process complex tasks. The CPU is using logical gates to process complex tasks. The CPU consists of billions of logical gates that are interconnected with each other, and by combining gate types like AND, NAND, OR, and OR not, XOR, and XNOR, engineers build small circuits like adders or memory cells, and these circuits are then combined into larger units like the LLU, the arithmetic logic unit, which together let the CPU execute complex instructions. And we as programmers, we don't need to understand all these different circuits and how the adder works, but if someone is interested in that, here's a link so you can find more information about that. But what we need to understand that are the logical operators, and so we need to understand the truth tables for these operators. And this one, the AND, OR, NOT, and XOR, that are also assembly instructions. Okay, so here's the first truth table. Just try to memorize and understand these truth tables, and then later in the video I will show how we can use them. Okay, so 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, and 1 and 1 is 1. And then just negate or reverse these results, and then you get the results for the logical AND. Okay, the next one is the logical OR. 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1, and 1 or 1 is 1. And again, reverse the results to get the correct results for the logical AND OR. Then we have the logical NOT, and there we have just one column, and here I just reverse the values. So 0 is 1, 1 is 0. Then we have the logical XOR, and that is basically the same like the OR, except there's just one exception. So here we can see 1 XOR 1 is 0, and if we go back to the logical OR, then we can see 1 or 1 is 1, and that's the only difference between the XOR and the OR. And here again, reverse the results for the logical X and OR. And this is how we can use the logical AND operator to check if a number is positive or negative. 1 byte that are 8-bit, and assigned byte, the highest possible value is 127, the lowest possible value is minus 128, and this is a binary representation, so this is 127. This one is the least significant bit, and this is the most significant bit, and here we can see that the most significant bit has a value 0, and that means that this is a positive number. Here we can see this is the byte as a bit representation for minus 128, and in this case now the most significant bit has a value 1, and that means this is a negative number. This is minus 128. Okay, now what we can do is, if we have this binary representation, and if we want to know if it's a positive or negative signed bit, then we can signed byte, then we can just use the AND operator. So that means here we have the bit representation for the 70. This is minus 128, and now we can do the following: compare all the numbers. Okay, so the first one is 0, and 0 is 0, 1 and 0 is 0, and so on. Just do that with every number. If you can't remember the truth tables, then just go back to this table or chart, and then you will get your answer. Okay, the next one. Oh no, at first, yeah. Need to talk about this again. So you can see now the end result is 0. And the most significant bit has the value 0. So that means that this is a positive number. So 70 and minus 128 is 0. The next one is a minus 70. This is a representation for minus 70. And again, use a logical, use an AND operator again. So 0 and 0 is 0 and so on. And then at the end, you can see this one. 1 and 1 is 1. And then we know already that this is a negative number because the most significant bit has a value 1. Minus 70 and minus 128 is minus 128. And then we have the XOR encryption and decryption. We can use that to encrypt and decrypt strings in a program, but I will talk about that in a later video. So yeah, for now I will just show you how to encrypt and decrypt the number, and maybe people with more experience know already that this is an ASCII. But yeah, as I said already, I will talk about that in a later video. So for now, just memorize that what I explain here. Okay, so we need an encryption key. I've used this one now, 128. This is 65. This is 128, the encryption key. And now we use the XOR operator. So again, 1 XOR is 0. 0 XOR 1 is 1, and so on. Just do that. Checks the result for every bit. And in this case, the end result is 58. So that is an encrypted result. Now we will do the same again, but now we will use the 58. So again, there's a bit representation for the 58, and this is again the encryption key, and again goes through all the bits, XOR them, and the end result is 65. So here is an encrypted result, and this is a decrypted result. And in the next video I will talk about CPU register.